Kinematics describes motion without ever asking what causes it. No forces, no mass, just the pure geometry of moving, where something is, how fast it goes, and how its speed changes. Get the language exactly right, and the hardest motion problem becomes simple bookkeeping. This unit builds in 4 moves: the precise vocabulary of displacement and velocity, the motion graphs that hide a wealth of information, the 4 Suvat equations that solve constant acceleration problems, and free fall, where gravity does the accelerating. Let's start by getting the words exactly right. 4 words, and the difference is direction. Distance is the total ground covered. Displacement is how far you end from the start, as a straight line with direction. Walk a full lap of a track and your distance is 400 meters, but your displacement is 0 because you are right back where you began. Speed and velocity follow the same split. Speed is distance over time, a scalar. Velocity is displacement over time, a vector that carries direction. And acceleration is the rate of change of velocity. Crucially, since velocity is a vector, changing direction is accelerating, even at constant speed. Motion graphs hide everything you need in 2 features, the slope and the area. On a displacement time graph, the gradient is the velocity. A steep line means fast, a flat line means stopped, a curve means the velocity itself is changing. The velocity time graph is even richer. Its gradient is the acceleration, and the area underneath it is the displacement. So a single velocity time graph hands you both how the motion is changing and how far it has gone. Read the slope, then read the area, and the whole story is there. When acceleration is constant, 4 equations connect 5 quantities: displacement s, initial velocity u, final velocity v, acceleration a, and time t. Each equation leaves one of the 5 out. The whole skill is reading a problem, listing the 3 you know and the 1 you want, then picking the equation missing the 5th. There is one rule that makes or breaks every Suvat answer: be consistent with signs. Choose a positive direction at the start and stick to it. Anything moving the other way, an acceleration that opposes the motion, must be negative. Most wrong answers are not algebra errors at all, they are a stray minus sign. Freefall is just Suvat with a fixed acceleration. G, about 9.81 meters per second squared, pointing down. Drop 2 objects of different mass in a vacuum, and they hit the ground together, because gravity gives every object the same acceleration regardless of its mass. Only air resistance breaks the tie. Throw something straight up and the symmetry is beautiful. On the way up, gravity decelerates it. At the very top, the velocity is momentarily 0, while the acceleration is still g downward. Then it speeds back up on the way down. The speed at any height going up equals the speed at that same height coming down. Here is the whole unit as one poster. Get the vocabulary right. Distance and speed are scalars, displacement and velocity are vectors, and acceleration is the rate of change of velocity, so turning counts. Then read motion graphs by slope and area. For constant acceleration, the 4 Suvat equations solve everything. List what you know, pick the equation missing the quantity you don't need, and keep your signs consistent. Free fall is simply Suvat with a equal to g downward, the same for every mass. And the boundary fence so you do not over-revise. What causes the motion, the forces and Newton's laws, comes in the next unit. 2-dimensional projectile motion and motion under a variable force weight for later. Here it is pure description. Words, graphs, Suvat, and gravity.